Hi, I'm Kevin Short, General Manager at Anza Electric Cooperative, and we're here today at the Tony Lappos substation, which was recently remodeled.
In reality, it's much more than a remodeled facility. The substation, which has been in service for more than 70 years, has been redesigned and completely rebuilt to incorporate the latest in modern technology.
All of the main structure in the original substation, which was built in 1951, was originally made out of wood. So old poles, timbers, cross timbers, all made out of wood. So the current design now is, as you can see, a steel structure, solid bus overhead, much larger conductors than they used to be, and all of the other equipment inside is much more modern.
In addition to upgrading the substation to meet demand for today and decades into the future, the Anza solar arrays and the battery storage banks, also cutting-edge technology, had to be incorporated into the existing grid.
This underground feed that comes overhead here comes directly from the solar array to our west. Now, it feeds through this circuit breaker and then interconnects into the 34,000 volt line overhead right here.
That 34,000 volts has to be stepped down so it can be distributed to Anza's members, again utilizing the latest in equipment and cutting-edge technology.
Out of the transformer that changes the voltage from 34,000 volts down to the 12,000 volts that goes on our distribution line, we feed these three voltage regulators, each one for one of the three phases on the distribution line. So the last step out of the voltage regulators behind us goes into this box structure right here, into the automatic circuit breakers that distributes to our four main circuits out of the substation.
The substation infrastructure is only part of the complex system that provides the power. It all has to be monitored to keep the energy flowing in a controlled manner. And for that, Anza Electric Cooperative relied on design, engineering, and technical assistance from Arizona Electric Power Cooperative, or APCO, of which Anza EC is a Class A all requirements member.
This is the control room for the substation. And it also involves controls for the battery and solar array that's, again, to the west of us here. So APCO's team came over and helped us install all of the equipment, the sensors, the wiring, all of this control equipment for the relays and protection scheme for the entire substation. We did have engineering assistance from APCO as well for the initial transformer design and breaker design. Along with all of the relay equipment as well.
Short said the project would not have been possible without APCO's involvement.
Without that kind of support from a G&T entity, basically the co-op's on their own. So from everything from planning, design, engineering, installation, that was critical.
Implanted into the design of the substation was a heavy emphasis on remote access.
Sandy King, Anza EC's engineering supervisor, says utilizing remote access technology was a priority.
We integrated the controls into the design of the substation to really allow access for remote monitoring and access to the system so it can be operated remotely. Over the last few years, we've had significant load growth, and monitoring all of our equipment and how it's handling that load, or that increase of load in specific times of the year, is really important. We've integrated alarms into all of our equipment to ensure that the equipment is working as it should, and also the ability for dispatch to look into those devices to either operate them, whether we're doing switching out on the line or something, or if there's a fault, dispatch can see that there was an issue and dispatch somebody to go look at the fault.
Now that it's finished and in service, members of the Anza team look back at some of the challenges, not the least of which was the COVID-19 pandemic.
During the pandemic, we had tremendous supply chain issues. The steel had to be ordered months and months in advance. The transformer was had to be ordered a year in advance. So a lot of supply chain issues.
Also, in order to keep the power flowing during construction, a temporary substation, very basic in design, had to be built.
We had to build a bypass, or what we call a shoe fly, to use this transformer, which we're going to be lifting out of here, and bypass the entire existing substation so it could be demolished and the new structure built. Yeah, it had to be done live. We took a minor outage late at night, but that de-energized the structure that was here, and then we were able to route the services around the substation.
Short said the years of planning, design, engineering, and finally, construction ensures the cooperative will be able to meet the needs of Anza's service territory and its members with safety, reliability, and affordability for decades to come.